Hello, this is Richard White with a brief presentation on Newton's first law of motion. Now, Isaac Newton was an amazing guy. He was an English scientist. He was born in 1643. He died in 1727. He was a scientist and a mathematician, and he's known for developing calculus to aid in his study of physics, and most significantly, perhaps, he's known for publishing in 1687 the Philosophiae Naturalis Principia Mathematica, which contained, among many other things, his ideas on motion. We're going to cover his three laws of motion, actually just the first law of motion today, the law of inertia. So we'll begin with a brief definition of this, and then we'll look at some examples. Newton's first law of motion states that an object continues its state of motion, whether at rest or moving with a constant speed in a straight line, unless compelled to change that motion by a net force. Now, that may or may not seem like it's a whole lot of common sense, but it's a real measure of Newton's genius that he was able to state this first law of motion so succinctly. So we're going to take a look at this using, at the beginning anyway, a soccer ball. We're going to try to examine some of the details here in Newton's first law of motion. So the first part states, a body at rest tends to stay at rest, and that's probably true. If you saw a soccer ball sitting on a football field or soccer field, and there was nobody kicking it, you'd be pretty surprised if it started moving all by itself. So maybe no big surprise here. But it's a measure of Newton's genius that he came up with a second part of his law here, his first law. A body in motion tends to stay in straight line motion at a constant speed. Now that's very unusual for things to do that. We only see that kind of thing, say, for objects flying through space, or if you had, say, a hockey puck on an ice-covered hockey rink, you might, if somebody gives that puck a nice slap shot, you'll see that puck flying across the rink, and you'd be surprised to see it slow down and stop because it's so low friction. In fact, it would continue flying right off the rink if there weren't that wall there to keep it from flying off the rink. So there weren't such things as hockey pucks and ice rinks in Newton's day. But he was able to imagine these kinds of situations. He was then able to envision a situation where there might not be any friction at all. The next part, the last part of Newton's first law, says, well, what happens if you don't have a force-free situation? What happens if there is a force? And that's much more like what you'd commonly see if somebody were to roll a bowling ball all across a field, or even a soccer ball. It's eventually going to slow down and stop because of various forces, mostly friction forces acting on the ball there. Well, let's talk for a moment about that tendency to maintain a state of motion. That's called inertia. And a measure of inertia is simply mass. The more mass you have, the more inertia you have. If you have a lot of mass, like this bowling ball, that means it's going to be hard to get you moving. Or if you're a bowling ball and you're already moving, that means it's going to be kind of hard to stop your motion. Compare that with a soccer ball. Very easy to run up to a soccer ball and kick it. It's got relatively low mass, so it's relatively easy to get it moving. You wouldn't want to run up and kick a bowling ball sitting on the field. You'd probably break your foot in the process. So mass is a measure of how much inertia something has. And because this tendency of an object to maintain its state of motion is called inertia, we sometimes call Newton's first law the law of inertia. You might well ask, well, what happens if there is a net force acting on an object? In this particular case, the moon, well, you can see it's got a velocity vector there, that red arrow pointing the direction of the moon's motion. The moon would continue traveling in a straight line at a constant speed in the direction of that red arrow, except for the fact that there's a force of gravity in this case, due to the Earth. So what happens as a result is the moon is pulled out of that straight line motion. And this is what's covered in Newton's second law. Newton addresses all of this in his second law of motion, and you'll get a chance to learn about that in the future. If you're interested in learning more about Newton and his laws of motion, you can check out Newton's laws of motion. You can Google that, specifically Newton's second law of motion. You can look at Wikipedia, learnconceptualphysics.com, learnaphysics.com, or socratica.com. This is Richard White with a brief presentation on Newton's first law of motion.